In the early 20th century, Ernest Rutherford, along with his collaborators Hans Geiger and Ernest Marston, conducted a groundbreaking experiment that fundamentally altered our understanding of atomic structure. This experiment is famously known as the gold foil experiment. Objective: the primary goal of the experiment was to investigate the structure of atoms, particularly to understand how positively charged alpha particles interacted with the atoms of a thin gold foil. Setup: 1. Rutherford and his team obtained a thin sheet of gold foil just a few atoms thick. This foil was selected because gold is highly malleable and can be made extremely thin. 2. They set up a source that emitted a stream of alpha particles, helium nuclei, each consisting of 2 protons and 2 neutrons. These alpha particles were positively charged. 3. A circular detector screen coated with a fluorescent material was placed surrounding the gold foil. The detector screen could detect the alpha particles and produce tiny flashes of light, scintillations, when struck by them. Expectations: based on the prevailing Thomson model of atomic structure, the plum pudding model, scientists expected that alpha particles would pass through the gold foil with minimal deflection. According to this model, an atom was thought to be a uniform, positively charged sphere with negatively charged electrons dispersed throughout. Observations: to their astonishment, the results of the gold foil experiment were not what they anticipated. Most alpha particles did pass through the foil as expected, but some exhibited significant deflections, and a few even bounced back towards the source. Conclusions: 1. Mostly empty space. The fact that most alpha particles passed through the gold foil without significant deflection suggested that atoms were mostly empty space. This result contradicted the idea of a uniform, solid atom proposed by the Thomson model. 2. Dense nucleus. The surprising deflections and backward scattering of alpha particles led Rutherford to propose a new atomic model. He concluded that atoms must have a tiny, dense, and positively charged nucleus at their center. The rest of the atom, he believed, consisted of mostly empty space where electrons orbited the nucleus. 3. Revised atomic model. Rutherford's model, known as the nuclear model, revolutionized atomic theory by introducing the concept of a central nucleus. It laid the foundation for our modern understanding of atomic structure. In summary, the gold foil experiment was a pivotal moment in the history of science. It revealed the existence of the atomic nucleus and challenged existing atomic models, paving the way for a deeper understanding of atomic structure and the development of subsequent atomic models, such as the Bohr model and quantum mechanics.